Hello. Hello. How's everyone enjoying it so far? Yes? Awesome. I feel like I got a pretty good time. Everyone's like still okay, buzzing from coffee, not quite hungry enough for lunch yet. I'll get some attention. No? Okay, good. Good. So this is me. My name's Eric. I am a software developer for a company in Ottawa called MB3, and we do some software for the United States government, specifically the states individually, to help with emergency management. You can come talk to us afterwards. That's like my super brief. It sounds really cool, so come talk to us afterwards. But I'm not going to go much deeper into that. So that's me. That's my Twitter. I'm not putting it anywhere else. So if you want to tweet at me during this, I won't answer you, but take a picture of that. Good. I also tend to forget things. I like to talk a lot. This is where you can find kind of the bits of information I've used, the slides here, some code snippets, that kind of thing. It's on my GitHub page. Should be pretty easy to find. Wonderful. All the good things are happening. OK, so welcome to my talk. My talk is on overcoming the async struggle with RxJS. No applause. Woo! Who here has heard of RxJS before? Good. That's actually decent. I did a talk at a meetup, and I was like, who's heard of styled components? And there was like 2 people. Who's heard of styled components? About the same amount of people. OK. All right. Interesting. Anyone use RxJS now in their applications? Less people? OK. I guess the Angular people aren't really here, so it makes sense. Good. OK. All right. Interesting. Interesting. Anyone interested in it? You're like, oh, yeah. Yeah, OK. I tend to see those ones go down. Good. So then, obviously some people are interested in it. Some people use it. Not very many. Not everyone, definitely. So why in the world am I here to talk about it is really the question. In general, why am I here to even consider different async options than those that already exist? Anyone want to tell me why? No? I don't really know either. Good. All right. So I feel like it's a good question to explore. It's a good question to explore. Like every time new technologies come out, you're like, OK, there's a new thing that exists. Let's figure out, is it good or not? Should I be using it? Should I be presenting about it at a conference? and these are kind of my criteria for async in general. When we talk about like promises or callbacks or generator functions, those kind of things in Rx, I kind of want to see these things. I kind of want, obviously, async to be handled. I toyed with including that, but it must be done. I have to be able to handle async. I want things to be chainable, so I can write nice code. I want Actually, you know what? I keep doing this. I have slides for this. Handle async. We need to do that. It needs to be chainable for that reason. Good. Multi-value. So this one's going to be, there's 2 here that I'm really going to toy with in your brain if I can. Multi-value is one of them. Promises don't do it. Generators kind of do it. Callbacks definitely don't do it. So multi-value, big thing for me. I love it. So JavaScript operators are great. Let's use those in async. And then last one is cancelable. And this is big. People know what I'm talking about when I talk about cancelable, right? We use like a ton of API requests and those kind of things nowadays in 2018. And we don't have really a ton of fine-grained control to say, OK, stop doing what you're doing application because you're breaking or those kind of things. Let me retry a bunch of requests because I'm not authorized. And our promises, we have to go around a lot of things in order to get that kind of stuff to work. So these are the criteria I'm going to use when I'm judging. I'm going to judge them pretty harshly when I'm judging all the other async options that I feel are useful and people use today. Good. This is pretty important. This subject is big, like all topics, in JavaScript nowadays. It's really big. So I can't talk about everything. I'm just going to scratch the surface a little bit. Please, you have questions, or I said something wrong, or you want to come and just dig deep about observables afterwards. Just come and talk to me, which I have a slide about saying that too. Come talk to me. I like slides. They do all the talking for me. Good. All right. This is actually the beginning now. This is actually the beginning of the talk, right? What do you think about when I say asynchronous JavaScript? Anybody? Nothing. No. Yes! Yes! I actually had something written different here, but then everybody at work was like, callback hell! And I was like, it's going in. So I'm glad somebody else said it. So callback hell. Callback hell is the thing we think about when we talk about asynchronous JavaScript. And it's not necessarily super true anymore. With promises, you can have some pretty linear streams of programming. But in terms of you think Node, you think JavaScript, and callbacks, you're thinking callback hell. And it's gross. It's bad. So don't worry, I'm gonna kind of blaze over that. I'm gonna try and avoid as best I can the callback hell and change your mind, hopefully, about asynchronous JavaScript. So the question is, what is asynchronous JavaScript? And how does it work? How does asynchronous actually work in JavaScript? Now, I have to do, this is a bit interesting because yesterday, Mary Snow talked about the call stack and these sort of things. I'm gonna go over it again. Her presentation definitely helped me out. But we'll go over this. So you have a program, and your program has a stack. And on that stack are function calls. And as you call and get deeper in the function stack, you're adding on top of the function call stack in a synchronous manner, right? Boom, 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 function calls. As you're going deeper in the stack, you're adding things on. Now, obviously, we've seen how asynchronous works. So this slide's kind of redundant. Like, what does it look like when we do async? And I had this very funny slide. You can't do this. This doesn't work on the call stack. It doesn't happen like that. That's not a stack. But we know that already from yesterday, which is good. So how does async actually work? And I know everyone, well, I hope everyone, maybe since yesterday, who was thinking that, wait a second, JavaScript is only a single thread. So how in the world can I actually make use of asynchronous code? And so you're right, like JavaScript is really a single thread. No one's judging me yet. I said that. JavaScript's a single thread. Good. All right. Good. The main thread, right? Like the main event loop thread. That's a single thread. You can't execute anything off of that especially when you're doing JavaScript. But your computer has tons of threads, especially nowadays with super powerful computers, right? We end up having like tons and tons of kernel threads and thread pools on your computer that luckily our Node.js and those kind of things can interact with. So they each have their own stack, which makes it nice that we can offload things from our main event loop into other threads to execute stuff. Good, and then Node.js and browser, that's kind of the things there that help us communicate between the main thread and those worker pools. Good, so eventually this kind of happens. I keep having this call stack on again. I didn't really want to go into this a ton, which I'm really glad that Mary Snow did, but this is kind of how it works. Very high level, very high level. So now we kind of have an understanding. JS is multi-threaded, sort of. It's multi-threaded. It's lovely. So then the question becomes, like, how do we take advantage of that? How do we write good applications in JavaScript using all those threads that our computers just have laying around doing nothing? Unless you're running Electron, and then they're not doing nothing, but that's OK. So the two typical things are callbacks and promises. Who has not heard of any of these things? OK, good. All right. I'm relatively happy. I'd be a bit worried if you didn't know what callbacks were, I guess. So we'll touch on callbacks first. I'm going to try and blaze over these. Here's a really simple little code snippet. Got some console logs in there. I'm just kind of writing to a file. Nonsense, right? This is the typical, I feel like, a typical example of Node.js. Right, I'm going to write a file, have a callback, that kind of thing. So the code is pretty simple. Do this thing first, write the file. When that's finished, call this function. If there's an error, I can print some errors, that kind of thing. So the thing about asynchronous code like this is that we have, when I'm executing, we don't execute in order, as we've seen yesterday. So we have, like, I'm about to write the file, and then I fully skip over that callback, right? Because the whole process hasn't ticked around. And then I print, I may not be done yet. And then I print, yes, I didn't break. Woohoo! Good. So that's how that works. It's lovely. They're not bad. They've worked for a long time in the browser in Node.js to allow us to do asynchronous code, which is great. But obviously there's a but with callbacks, and they look like this. And I feel like this example doesn't do it good enough, where you get that like nice arrow of just infinite forever going on. And that's the callback hell we kind of want to avoid. So here it's kind of a nonsensical example. I'm like writing a file, then making a server request, and then writing a file after that. And you can kind of see that's just going to keep going on and on and on and on. And if I have to wait for those things to happen, you can see that that's just going to go forever. So I'm a big fan of emojis. That's the face I feel like when I see these pieces of code. Just like, oh, I can't, I don't, it's bad. 24 lines, I can probably deal with it. Hundreds of lines? No, I can't do it. It's going to hurt my brain. So callbacks, all they do is handle async. That's all they do. That's all they're good for. Moving on. I give it a big thumbs down. I'm not against callbacks, but big thumbs down. They suck. They're not good. Good. All right, on to more recent times. Promises. They're really great. Promises. This is what they look like. So it's the same example. It's a bit smaller, right? It's much nicer to write. It's like linear this way. You don't have like these nested situations. The same thing still happens if I have, I'm about to write a file. It's going to skip over that promise and print. I may not be done writing the file, then print I'm finished. But in any case, that's the promise. They have these nice features, so it's like the language around it is nice. I'm writing the file, and then I can say, well, then I want to do this thing, but if there's an error, I'm going to do something else, which is really lovely. But the best part about promises for me is that the .then and .catch syntaxes, like, they implicitly return promises themselves. So inside of there, you can like return promises up and keep that linear chain, which is just really nice, which is the huge benefit, I feel like, of people coming from callback hell into this, which is that I can now read my async code, which is amazing. Right? Oh, did it get cut off, everybody? It did. Good. So this is my example of returning an implicit promise, right? I just did a console log, but then I did a .then after that, so that implicitly returns a promise of whatever that function returned itself, which is undefined. So I got undefined. It's very exciting for people. But that exact example makes chaining really nice, right? That makes us able to like nest these things, and since these things return promises, I can then like move grouped like promise things together. So instead of kind of jumping out of flow to finish off a promise and get JSON from a request, I can keep it inside and do that sort of thing, which makes like writing them this beautiful. It's so much better to read this code than the code you previously saw. You can reason about it a bit more, that kind of thing. You write like huge chains. Hundreds of lines is fine because you can follow it like in a linear order. I love this part about it. This is maybe not the best thing, but you can catch all your errors in one place. This is a horrible pet. Don't do this. You should probably do more catches than just one. But at the end, if you really wanted to, you're like, yeah, any error that's ever thrown in any of these promises, don't worry. I can handle it somewhere with like one catch-all, which is super nice. With callbacks, right, you couldn't really do that. You'd have to handle it in every single one, which added to the bloat of what happened inside of callback hell. And then, obviously, async await. Can't go on talking about promises now without async await. Who uses async await? Good. Anybody not like async await? Good, OK. All right, good. Everyone like super in love with it, like get away with everything else, only async await. Interesting. OK, cool. So I'm not going to go super deep into async await, but it pretty much just makes your async code look synchronous, which some people really love. I'm not going to include myself in the people that really love that, but it's OK. It's fine. It serves its purpose, right? It makes it look synchronous. That's really great. Reading code like that is sometimes nice. So promises offer us like a ton of flexibility, right? We can return promises within promises and keep them linear, but we don't have to. We can make them really long. We can catch errors in different places and those kind of things. But in general, they are way more flexible than callbacks. Callbacks can't really do much in. Which ticks off another one of our boxes, which is that it's chainable. So it does async, which is great. It's also chainable, which is amazing. But it's still kind of lacking two things. We'll touch on it. Promises are good. Now, we still use promises a lot. I still use promises a lot. And even with the next thing I'm going to touch on, which I think you all know what it is, we still use promises in that. Like they're still useful. They will continue to be useful for a little while. So I'm still giving them a thumbs up. I'm not quite as angry at them as I am as callbacks, but that's OK. So obviously, you're asking me if I'm giving a thumbs up to promises, then like why are you still here? Promises are the best. We're moving on. Nobody's got problems with them. We're all able to write huge products in JavaScript and make money and those kind of things, and promises are still here. So why am I here? I'm taking here for photos. Good, all right. No, but really, why am I here? Why am I here talking to you about asynchronous code and saying promises are good, but we're moving on? And that's because they're not good, right? We've been kind of living with them because of the only thing we have really in this time period to be doing asynchronous code, but they're just really not good enough. They don't give us the multi-value processing we want, especially nowadays where we're having tons of API requests and things going on in order to have a single application work. We can't have a single like array then, like promise.all, that kind of situation. Like we're working with JavaScript objects now, and it gets very messy. And then the big thing, cancelable, like we want that fine-grained control. We want to be able to say, if this request failed, I want that one to stop going, but this one can continue, and I want to retry if that one happens. And getting all that done in promises is not simple. You can do it, but it's not simple. So what's the answer to all those woes you didn't know you had that I've just introduced to you? And yeah, what technology will actually allow you to do all these things like nicely? I guess you can do them now, but what will actually allow you to do them nicely? Chainable, multi-value, cancelable. For me, I say that. I want it to be opinionated. I put this in here for other people, but for me, I always choose this. It's reactive programming, reactive X. No, OK, that's good. All right. No one? Yes, good. So reactive programming. Anyone ever seen this website before? Good, good. All right, cool. They have a neat tool, actually, but it's OK. You can like type in English phrases, and it tells you how to use things. And good. It's a good website. So more generalized, what is that ActiveX? What's going on? It's the observable stream programming paradigm. No one's heads are exploding yet. OK, good. Mine is. Good. So it's streams. In general, you can think of these things as streams, observables. There's a ton of words around them. And I think that's the scariest part about reactive programming in RxJS in specific is like the words. Like there's the operators and like observers and subjects. And you're like, I don't know what's happening. Tell me how to write async code. I don't understand. It's not then. That's beautiful. So they're just streams. In your mind, they're just streams. Kind of a problem. They're not native. So everyone's pretty happy because promises have been native now for a little bit. These are not native yet because there is a proposal. Stage 1. We're getting there. But it's not. So we'll talk about libraries. And that's where that website came from. It's like a library for these things. So the 3 that I'm big into right now are these ones. You can go, these are actually links, so when I give the slides, you can go and check them out. 2 of them are actually written, or like, I guess, created by the same person, but really good stream libraries. We'll talk about this one. It's lovely. I'm going to go into that, I guess. So how does Rx actually solve your problems? I've introduced all these problems you didn't know you had. How do you go about removing all the promises from your code? Because that's what you don't want those anymore. They're junk. You can't do stuff with them. And replace them with RxJS. So this is the, man, it's too bad my resolution's not good. This is the partial, I guess, write file example with a promise where I'm doing kind of like this, write a file, then do some fetching, and then translate it back to JSON, and then write another file after that. So it's OK. It's really actually quite nice in promises. We can work with this. We can write large applications with this. This is the same code in observables. The write file got cut off. Please, just for now, ignore the switch map. It looks bad. The language is weird, but ignore that. It's pretty much the same thing, though. You have exactly write the file, fetch some data, write the file, and then we finish with our both error callbacks or not error callbacks. Right? It doesn't look too different. It's not bad. Anyone scared yet? Someone saw us. Yeah, good. At least one person has to be scared. Switch map? What is happening? Subscribe? I don't know what's going on. Good. All right. Only one person. That's not bad. OK, so before we actually get into what the heck is that doing and how does that help me and those kind of things, we got to talk about what are observables, what are streams, what are those things. I'm just talking about words. We don't know what's happening. So we'll talk about data. Like core stuff, data. This is like, in my mind, the data types that exist in JavaScript. Numbers, strings, booleans. Everyone's seen that. Anyone not seen these? That's good. OK. Good. You can get by, I guess. Now, this is kind of a core concept for me. This is kind of how I think about observables and what makes them less scary. Is if you think about data in terms of lists. Now, if you're like used to doing functional programming, this is pretty comfortable to be like, oh yeah, data is lists, no problem. But in general, this is pretty much how you can represent all the data types in JavaScript, but as lists. So you pretty much just put square brackets around them, and then it's a list. But it's the same data type, but it's a list. Good? Everyone? Yeah? Cool. And then this is empty. Right? That's an empty. So any number, that's an empty number. Right? It's not like null anymore. It's this. Good? Everyone's feeling comfortable with that? OK. You told me to do it. Now this is observables. It's like the same syntax, right? There's a few more characters. It's not nicely angled brackets. But this is pretty much the same thing, right? So you have an observable of the value of 1, or the observable of the value of a string, which take the word observable, take the word stream out of it, and it's fully just I have a value of 1, a value of a string, I have a value of a function, I have a value of a list, those kind of things. And now this is what did it for me. But empty, they use the keyword empty in there. It's pretty clear. It's good. This does weird stuff though, so I mean, be careful. So they look the same thing, right? And for the rest of this conversation we're about to have together, conversation I'm talking at you, please just conceptualize them as lists, right? I'm talking to say observables, I'm going to say like streams, but they're just lists. They're just lists of values inside of them, and that's that. Cool. This is where we get into the power of it. So this is manipulating list and manipulating observable with the same operations. Right? We have map and we have filter. The 2 core, you could put reduce in here. It does have reduce. I thought I'd leave it out just in case people weren't super comfortable with map and reduce and filter and that kind of things. But in general, we have a list and a stream, an observable of the values of 1, 2, 3, 4. And we do the same operations. First, I map over them and add 1. And then I filter out all the even ones. So I just am left with the odd ones. And you can see they produce the same result. And they look exactly the same. I say exactly the same. One could subscribe in it, but we can ignore that. Good? Less scared now? Less scared? No, still scared. OK, good. The crazy part is that is fully asynchronous, right? Writing that code right there with the map and the filter, it looks synchronous. In your mind, I told you it's lists. It's lists. And that's synchronous. Those are fully asynchronous, not on your stack. You can continue programming beyond that. Those won't even run. I mean, they will, because they're like lists. But that's like, this is the crazy part about observables. Map and filter. Can you feel the power? Can you feel it? Could have got some laughs. My wife was like, no one's going to know the movie. No one's going to know the movie. Good. So you can do not just all of the list operations, but more, but all of the list operations on your async data. And that itself is asynchronous. If that's not blowing your mind, I don't know what is. I can't say anything else that's going to be like, maybe I'll do a somersault or something, a backflip. That'll blow your mind. I can't do that. Don't expect me to do that. Good. OK, so I've been showing you these little examples. Like, yeah, I can write some file that doesn't make any sense. I can do some network requests that are kind of nonsense and those kind of things. But like, actually, how do you use this? How do you use these in the real world where we're making API requests and multiple of them and combining them together and doing all those async operations that we want to do with promises? How do we do it with observables? No problem, I say. I will tell you. So let's just take some data, some actual real-world data that you can go now and manipulate. This is GitHub's developer API. I didn't do token stuff. I went with like git ignore. They have like a bunch of git ignore templates. And so I was like, let's just manipulate those a bit. They have all the data there, right? So when you start a new repo, you can say, I want to like have a git ignore for Node.js, and it'll give you some git ignore pre-populated. So they have an open API for this. So let's just use that. And all I want to do is I want to just take all those templates, because they're two different requests. I want to like get all the templates first. I want to read them all in. Then I want to like get all the data for each one of those templates, and then write all those to a file. Like simple, right? 2 network requests, write to a file, 3 async operations. In promises, people are trying to picture it in their mind. They're like, oh, how am I going to do it in promises? It's junk. It's not easy. But in observables, like this is where it gets beautiful. So I'm going to show you code. We'll see how it goes. We'll see how it goes when I show people code. This is fetching the data. As I said, I haven't fully gotten rid of promises, but observables are nice, RxJS in specific. They allow you to do this from JS. They can take any promise in, or from JS, I said, from JS, from promise. Take any promise in and convert it to an observable for you. All that is, like if you picture an array, right? I have a promise inside that array, and I'm just getting the value outside with the array still. So that's it, nothing special. This is where we get into the craziness. Switch map, oh boy. So now, of course, because it's fetched, we need to get that JSON, which also returns a promise. So I'm doing this magic. Just believe me, it's magic. No, I'm going to tell you what it is. Switch map, what? This is the scariest operator. It's like used everywhere. You're like reading observables, switch map is there, right? And you're like, I don't know, this is a barrier. I don't know what's happening. So I'm going to tell you what's happening. So from promise, right? If you think about it again, we have an array. We've returned some object, the fetch or whatever, and that gives us that object back, that fetch object I called it. I don't know whatever's in there, some nonsense. I actually don't know. Right? Some stuff's in there from promise. Then I need to get the promise out of the JSON. So I want to get the JSON data out of that request. So there's that .json function that returns a promise as well. So we don't really want to end up with this, an array of 2 things now, because we're iterating over it, of the fetch object and the fetch JSON. Like it's the same data, just in 2 spaces, right? And observable guys, they were brilliant. They're like, this is a problem, because then how am I going to work with this data? It's not going to work. Switch map just replaces it. We're like, I've been collecting things as I've been going and adding them onto the array, but really all I care about is that last one? No problem. Switch map replaces everything with the one at the very end. So there you go. Now you know how that works. Just replaces it. Now it's done. I had a big problem with this. I still do. It's not an easy thing to understand. But so fetch JSON. That's the only object now we have in our imaginary conceptual array, which is an observable. So the crazy part is I fetch this stuff, and it's a big list of this is a proper list, a proper array, like a JavaScript array of strings now, right? So if we did a promise thing, that would return us this array of strings, which is lovely. So like again, we have this, an observable of an array. So going back to that imagination we had of what it looked like as lists, it looks like this. So it's a 2D array, if I could use that language. It's an array where it's only got one element, which is another array, which then has a bunch of elements of strings inside. People are starting to cry. It's not easy to work with something like that. What we want is to take this sort of thing, which is what promises do, and give us an array with a single value back, and work with each element of that, right? We want to work with just a single string all the way through, like you would with a flat list in JavaScript, right? Which is what Promise would do. Give us that list, we'd map and filter over it, but synchronously, and it'd be lovely. So observable of multiple values. Good, you can see where I'm getting at. Which is just this, and I've just removed the square brackets. That's the magic that I've done here. But this now creates a stream, an observable, or a single list of just each one of those elements, right? Which is just strings. And to do that, there's another operator called switch. So all it does is I've got that list in, I call switch, and all of a sudden now I have an observable of single items. So it's like a lift. And now we're working with individual values. So now what do? We have all these values. We need to get the actual content for each of those files, and then from there, write them to files on your disk. So fetching the content. This is beautiful. I just kind of put this in here so it doesn't look crazy. I didn't want to do this over and over again. It's gross. So I just put that in its own function that returns an observable as well. So I don't have to do the .json every time. It's just quite annoying. So that is it. So I've done that fetch request. I've done that lift, that switch, so then I'm working with each individual element. And now okay, another one, merge map. It's crazy. It does exactly what you think it does, though. It maps over each one of those strings, and instead of returning a string back again, it returns whatever value of the promise that was resolved inside. Or observable in our case, right? It's another fetch. So I've said, okay, I get like C++ in, or Go. I used Go. So I get Go in as an example as a string, and I want to get the content from that. So I do another fetch request saying the template is Go, hit up that API request. When it comes back, I now get this nested object in my list of the name and the source that's there, right? Yeah, that's like, I feel like that's like amazing, the power in sort of a merge map. Anyway, okay, that's good. Good. The names are bad, but it's good. So we have this now. We've gone over every single one of our strings, and we've replaced them all with still the same size list with a bunch of objects that look like this. You have a name with the name of the language that the getignore file is for, and the source that's inside of that. And obviously, we just want to write it into a file. So there's also a handy utility like promisify from Node to transform any like callback function that returns that uses a callback to return an observable, just like promisify. So we take a file like that, and this is the whole source code. This is it. This is all it is to make 2 network requests plus write things to a file. Boom, just like that. Now I threw in this map too at the end over here because write file, right? FS doesn't return anything. It only returns if there's an error. Otherwise, you get no data, it gets you undefined. But I wanted to print out something pretty like, oh, I've finished writing this file. So I carried the name along with me. Cool. So we just did another merge map. Obviously, we're getting those objects inside each time. We're saying, okay, now just you have the source, you have the name, write that to a file. Oh, I missed it. Write that content to a file. There we go. Good. This is really quick. Boom. That's it working. Prove it. It's on GitHub. You can use it. This is how it works. It's really quick. I don't expect you to read that. That's just spitting out all the names of things. Then I do a quick ls to show you that it actually wrote the files. So this is what it does. It does all the things you actually want asynchronous to do. You want to do multiple values. You want to do chainable things, so it's like nice readable code. You want to actually handle async. And I didn't touch on cancelable, so I'll just really quickly do it because those examples can get quite complicated, right? Especially if you think when's the use case for using a cancelable thing. It's like when you're making multiple requests and one of them fails, and kind of mocking that environment isn't really easy. So we did kind of a bit of a silly example. So here, I don't know if you'll be able to see it yet. Ah, good. I wrote a really quick observable. I was like, okay, I just want to like fire off every second, have an element added to my observable. I'm just going to print every second. But what I want to do is I want to stop when I click on it, right? Which is like canceling. I want to have this thing doing its processing, but then stopping it, but when I click on the screen. So I got to go click on the screen. How many seconds should I wait? I've clicked, and it's done. So like it's this amount of code here, ignoring the imports because I had to use CodePen, and this like append to DOM function, just so I could trying to remove the nasty part of actually writing things to the DOM without React and those kind of things. I've literally created one observable over here, one observable over here, and then done like 2 operations. Right? I've mapped over it. Map. This is some funky like pipe stuff, but map and then take until, which is one of the utilities that observables or RxJS offer us, right, to listen to other kind of things, tell me when to cancel it. I can also have array operators like take, so I can be like only 5 of them. That's all I want. stop after 5. We have those type of utilities as well, so that we can provide canceling. And it hasn't printed anything else. I didn't do any magic. I fully just clicked. Good. So it literally gives us all of those things: multiple values, synchronous code, cancelable, right? All the stuff that we can write very async code now and have fine-grained control of it, and not have it look messy and out of control and nested and all kind of things. Again, didn't include the GIF this time, but can anybody starting to feel a bit of the power of Rx? No, a little bit? I touched on like 3 operators. There's like hundreds. There's hundreds of operators. There's just kind of the scary part. You can manipulate data in so many ways inside of those chained operations. It's amazing. So it's clean, it's declarative, it's functional if those are the things you like. I particularly like functional code, but those kind of things are nice. They allow like code bases to be readable and maintainable even by other people who are coming in, because they can read that and understand what's happening. Obviously, once you understand what switch and switch map to. Good, so RxJS, stars in the eyes. It's beautiful. It's the thing you should be going home right now, or back to work, I guess, and replacing all your promises with. Don't tell anybody, just get rid of them. People laugh, but that's what I did. So and now we use it. We use it. So a quick recap, because I think it's important that we remember all the previous things that led us here, which were callbacks. We started off with callbacks. They're done now. They're just done. We're not going to use callbacks anymore. Good, promises. So promises are really good. They allow us to make network requests and get that data back, and then manipulate it inside of JavaScript, which is really great. But again, they do that hopping in and out kind of thing, where we make the network request, that goes off in the stack, but then we come back, and then we have to be synchronous inside of there. We have to execute things in order. And then RxJS, which gives us all those other things. Right? It allows us to make network requests, bring those things back, work with many values asynchronously at a time, and stop when you want to, those kind of things. And that's it. That's all I got for you. Thank you. Good. Any questions?
When does the actual fetch execute?
That's a great question. So the question was, when you're composing all these things, I'm doing a bunch of operators, when does it execute? It's kind of a neat thing about observables and about streams, is it never executes until you do the subscribe operation. So it will actually just kind of, it will just compose these functions together, passing the results of each value through, but won't run any code until you hit subscribe. Yeah, no problem. I feel like people are just like, I have no question. Oh, yes!
Is there any...
I feel like the guy sitting next to you told you to ask that question. So, so the question was, are there any problems debugging these sort of things? Yes. Yeah, because it's asynchronous in a different way, it kind of sits off your stack entirely. So when you get an error, you just get a bunch of source code from RxJS being like, oh yeah, there was an error somewhere in your stream. So when you're doing composing of large packages and large streams and you have an error, it does get a bit difficult to decode. Now there are packages and there are solutions, and I know that they're working hard to solve that, but until then that is kind of an issue, yeah. Yes?
Which testing strategy maps best to testing observable?
Interesting. You mean like a unit testing, or is that? Okay, yeah, okay. So the question was, what testing strategy maps best to using observables? I don't know if it really matters. I think you can test them very well in integration and in unit tests. You won't really see them. You only work with them when you're doing like end-to-end, things like that. Even integration might be a bit high level. There are really nice libraries to mock out for unit tests, to mock out observables, and to really expect exactly the operations to happen at certain times and that sort of thing. So I would say the preferable way of doing it is unit testing. But they're really functional, right? So ideally they should be kind of pure functions. But yeah, so unit testing, I guess, is the answer. Good. I could talk about this for days. So please come in. I won't talk about it for days, but please come and talk to me afterwards if you have any questions, or again, I said something wrong because I feel like I said it a lot. Good. Thank you.